Okay, let's have a quick go at this question. It goes, air is being lost from a spherical balloon at a constant rate of 0.6 meter cube per second. Find the rate at which the radius is decreasing at an instant when the radius is 2.5. Now, let's just write this all down. So it's saying air is being lost, spherical balloon, so it's talking about the volume. So dV dt, the volume is decreasing at a rate of 0.6 meters cubed per second. Now it's saying decreasing, you can call that negative or you can just leave that alone. It doesn't really make a difference, but when you're describing it at the end, just remember to say it's decreasing, or you will have to just leave it as a negative, which implies it's decreasing. I'm just going to leave it alone at the moment and see how it falls for me. So that's decreasing at that. We want to find the rate at which the radius, so the rate of radius, dr dt, is decreasing at the instant when radius, it tells you here, radius is equal to 2.5. So we've been told that, and we need to work that out. Now the way we work that out, dr dt, we've been given dv dt. We need to get rid of the dv. I need to introduce dr. So we need to find out how are v and r related. Now from your GCSE, you should know that the volume of a sphere is 4/3 pi r cubed. That is formula. Sometimes they'll give you that in the formula booklet. They should do. If they don't, it'd be a bit mean, but you should know that. So the first thing I could do is I could differentiate this dv dr, which is take the power down, take 1 to the power. So if I take the 3 down, 3 will cancel with the shared by 3, leaving me 4 pi r, take 1 off the power is 2. So we got that. But note here, it says dr dv. So what can I do here? I've got dv dr, but I want dr dv. What can I do? I showed you a trick earlier on. What can we do easy to find that? Yeah, reciprocal. We just get the reciprocal of this. So dr dv is just 1/4 pi r squared. So now we've got that, and we should be able to find this. Okay, and we know that we want to find it at that point. So therefore, dr dt, the rate at which the radius is decreasing, is going to be 0.6, so we change that for 0.6 multiplied by 1/4 pi r squared. So that's the same as, well, that's going to be 3/5, so that's going to be 3/20 pi, and then the r squared is 2.5 squared. Personally, I will just plug all this in your calculator, which I'm going to do. So 3/20 times pi times 2.5 squared. And your calculator gives, well, my calculator gives me 7.64. I'm going to do it to 3 single figures times 10 to the power minus 3. If you want to put that down as, you can rewrite that as 1, 2, 3, 7, 6, 4. Now, don't forget the radius, so radius is in meters per second. So, don't forget this is the rate of increase. If you want to leave it like that, just be careful. If you leave it like that without any wording, you should put a negative. Okay? You can either write a negative there and put a negative there, or you can write radius is decreasing. Sorry, I should have paused. Let me write that again. Personally, I will just leave it as I told you above, but if you want to write it in words, you could write rate of radius is decreasing at 0 point, then we put it as a positive 764 meters per second. Okay.